Very good morning to all. In the past few classes, we are discussing about the colligative properties, and we have discussed relative lowering of vapor pressure, depression in freezing point, elevation in boiling point, and osmotic pressure. So, today we are entering to a new topic. This is, I think this is the last section of this chapter. So in this last section, we are discussing what is abnormal colligative property and what is Van Hoff factor. The two new terms are abnormal colligative properties and Van Hoff factor. So generally, when we considering colligative properties, we have taken dilute solutions. Why we have taken dilute solutions? Because dilute solutions behave ideally. In dilute solution, the solute concentration will be very less compared to the concentration of the solvent. So, it will behave like an ideal gas. Based on that, we have studied some of the Van Hoff laws. Okay, so today our first topic is abnormal colligative properties. What is meant by abnormal colligative property? For a dilute solution, the experimental value of colligative property is in agreement with the theoretical value. There is no difference between the experimental value and theoretical value. But this is not always the case. There are certain substances like solutions of salts, acids, bases in water or acetic acid in benzene where there is a difference between the experimental value and the calculated value. So generally for dilute solution, the experimental value will be in agreement with the theoretical value. But in some cases, for substances like salts, acid, bases in water or acetic acid in benzene, there will be a difference between the experimental value and calculated value of the colligative property. So these solutions are called abnormal solutions, and this property is called abnormal colligative property. Then these abnormalities are of two types, or the abnormality in colligative property arises due to two reasons. The first reason is association of the solute molecules. Here, many organic solutes in non-aqueous solutions undergo association to form bigger molecules. Thus, the effective molecules decrease and also the value of colligative properties is less than that calculated on the basis of single molecule. For example, acetic acid in benzene, chloroacetic acid in naphthalene. Hence, molar masses of solutes in such cases will be higher than the true molar mass. So, as a general case, when we add a solute into a solvent, if we are adding n number of solute molecules or solute particles into a particular volume of solvent, we expect there will be n number of solute particles in the solution because we have added n number of solutes. So the solution in the solution there will be n number of solute particles. But in certain cases, these solute molecules will associate or combine together to form bigger molecules. So what will happen? We expect there will be n number of solute particles in solution, but the actual case will be the number of solute particle in solution decreases due to association. The molecules will associate to form bigger molecules. So this will cause a decrease in the molecules. So when the number of solute molecule decreases, what will happen to colligative property? We know colligative property is directly proportional to number of solute particles, or it will only depend upon the quantity of the solute particle, not the nature of the solute particle. So when the number of solute particle decreases, colligative property also decreases. Some of the solutions for association. Examples are acetic acid in benzene, chloroacetic acid in naphthalene. When we add acetic acid as a solute to a particular volume of benzene, the acetic acid molecule will associate. So what will happen? If we add two molecules, these two molecules will combine or associate to form a bigger molecule. So we have taken two, but in solution there is only one molecule. So there is a decrease in the number of molecules, so that the colligative property will decrease. Then what happened to molar mass? As the colligative property decreases, the molar mass of solute will be higher than the true molar mass. So in the case of association, this is the first reason for abnormal colligative property. In the case of association, the solute particles will combine to form bigger molecule. So the number of solute particles in solution decreases, hence colligative property decreases. Molar mass of the solute increases. It will be higher than the true molar mass. This is the first reason for abnormalities. Then the second reason. The second reason is dissociation of the solute molecules. In the first case, we have discussed association. In the second case, we are going to discuss dissociation. What is dissociation? Dissociate. Inorganic acids, bases and salts in aqueous solution undergo dissociation to give positively and negatively charged species. Dissociation means splitting. For example, when we add sodium chloride, NaCl, in water, or the solution of NaCl, aqueous solution of NaCl, the NaCl will dissociate and exist as Na plus and Cl minus ions in solution. What will happen? We are adding 1 mole of NaCl to the water. Then in the solution, NaCl will dissociate and it will give 1 mole Na plus and 1 mole Cl minus. So actually we are taken 1 mole of NaCl, but in solution there will be 1 mole Na plus and 1 mole Cl minus. Totally there will be 2 moles of solute particle. So there will be an increase in the number of particles in the solution. In the previous case we have discussed there will be a decrease in the number of solute particles because the molecules are associating or combining. Here solute particle undergo dissociation. Hence, the number of solute particle increases. So, as the number or quantity of solute in solution increases, what will happen to colligative property? Colligative property also increases because the quantity of solute and colligative property value are directly proportional. So, number of solute increases and colligative property also increases. This is the case, or this is the causes of abnormalities. The first one, association of the solute molecules, and the second one, dissociation of the solute molecule. So, these two causes a difference in colligative property, or there will be a different value for colligative property from our expected value. So the two reasons for abnormalities are association of the solute molecules and dissociation of the solute molecules.